Hello, everyone. Thank you for showing up for your learning today. Today we're reviewing lesson 1.5, solving quadratic equations. We want to be able to take equations that are quadratic in nature. They have an x squared, and they're also equal to 0. And we want to be able to find the values for x. Okay, so let's take a look at these. Our first one, 3x squared minus 2x minus 2 equals 0. First step is always copy down the question carefully. And then we might check for factoring. We might check, can I factor this expression? And how would I check for that? Well, I'm going to look for numbers that multiply to a times c. So that would be multiply to minus 6, 3 times minus 2, and add to minus 2. And then I find such numbers don't exist. Like if I try negative 3 and 2, that adds to negative 1, so that's not negative 2. And then if I try something different, like I try negative 6 times 1, well, that adds to negative 5. So it won't work. It won't factor. That does not mean that there's not solutions that don't exist. Okay, so here's how we find the solutions that do exist. We're going to copy out our a, b, and c values. A is equal to 3. B is equal to minus 2. C is equal to minus 2. Okay, I get those values here, here, and here. All right, and I put them into a handy dandy little chart for myself because you know what's coming next, everyone. I'm not singing for you today, but we're going to use quadratic formula. And we've been asked to give exact answers. So we're going to give the output of the quadratic formula after we simplify the radicals. Okay, so x is equal to negative 2. How many of you, raise your hands, have made a sign error when using the quadratic formula? Notice how careful I am with my substitutions. Okay, and I take up lots of space and I write it out very clearly and I substitute into brackets everywhere. Negative 2 squared, 4. Minus 4 times 3 times negative 2. Two negatives in this problem, minus 4 and minus 2. So this is going to be plus 24. Okay, 4 times 3 times 2 is 24. The answer is positive because there's two negatives there, all divided by 6. X is equal to 2 plus or minus the square root of 28 all over 6. But the square root of 28, okay, let's take a look at that. 28 divisible by 2. Divisible by 2. Okay, there's a square in there. There's 4. 28 equals 4 times 7. And 4 is a square. So this is x is equal to 2 plus or minus 2 root 7 divided by 6. Now reduce your fraction. Take out the extra factors 2 and the terms in the numerator and the denominator. These are the two values of x that will satisfy this quadratic equation. Isn't that delightful, everyone? I just put it into the quadratic formula and didn't make mistakes. That's the key to answering these types of questions. You'll also want to know how to reduce radicals. Okay, let's keep going, everybody. Now the next one, 6x squared minus 23x plus 20 is equal to 0. Now I could throw all this into the quadratic formula, but this one factors. Okay, so I can find that out by noticing 6 times 20 up here, and I want to multiply to that, and I want to add to negative 23. Okay, let's phrase this in a different way. I could say that I could say it's 120 up there, but you know me, I like to write it down as its factors. So instead of doing that, what I'm going to do is do a prime factorization of 120. And it's easy to do from here, right? 6 is 2 times 3. 20 is 4 times 5, which is 2 times 2. Okay, so we're going to have 2 times 2 times 2 times 3 times 5. 2.2.2.3.5. And now I can play with the different factors there and find the combinations that are going to add up to minus 23. Okay, now don't be scared of the negative sign there. You just know that they're multiplying to give you a positive number, adding to give you a negative number. So both of these numbers that we're looking for are negative. That's all. Okay, and then looking at this, I can see, well, 8 times 15 would equal 120. And negative 8 minus 15 is minus 23. All right. So that's going to be how this factors. So we're going to have 6x squared dupe minus 15x minus 8x plus 20 is equal to 0. Okay, I just broke this 23 down into two pieces. Now let's factor each one of these. 3x will factor out of the first two terms. So we're going to say 3x multiplied by 2x minus 5 would give me back the first two terms. I just divide both of those terms by the greatest common factor. I spot it because I know 6 and 15 share a factor 3 and they share a factor x. So I common factor those out and I divide each of these terms by 3x to find what remains in the bracket. The next one, the greatest common factor of 8 and 20 is 4. So I can remove a 4 and then I will have 2x. I'm removing a negative 4 here, so it's 2x minus 5. I divide negative 8x by negative 4 and positive 20 by negative 4. That's what gives me this stuff in the bracket here. Let's carry on. The last thing to note is that, this is still all equal to 0. Okay, so I see 3x minus 4. Each one of these terms is multiplied by 2x minus 5. So 2x minus 5 is the common factor. Multiplies 3x minus 4.
Excuse me, Daddy.
Go on. Okay, let's keep going. So 3x minus 4 is equal to 0. So let's see. We know that if 0 is the result of some multiplication, then either this term or this term is 0. So let's find the possible x values that make it true. Either 2x minus 5 equals 0, or 3x minus 4 equals 0. One of those two terms has to be 0. And in fact, either one of them could be. That's what gives you your two values of x. So let's solve this one with inverse operations. So here I'm going to isolate my x's by adding 5 to both sides. Here I'm going to isolate the x by adding 4 to both sides. Okay, let's see what our next lines are going to look like. This is going to be 2x equals 5 on that equation, and 3x equals 4 on that equation. If you're someone that's already saying to your screen, Mr. Jennings, I know this, I know how to do that, you're showing me a lot of steps, I just read it from the beginning, that's good, you just do that. Here I'm multiplying through 3 times some number and I get 4, so if I divide both sides by 3, that will give me the answer. Here I have x is equal to 5 halves, or x is equal to 4 thirds. Notice that if you decided to use a quadratic formula, you should have gotten the same answers. And if you didn't, you probably made a sign error. So be careful with that. Okay, be careful with that. All right, so circle those, because those are your final answers. You were looking for the values of x that made this true over here. And those are the two values that will work. Let's keep going, everyone. Question number 10. This one says use the discriminant to determine the number of roots for each equation. Okay, well, let's do a little quick tour of the anatomy of the quadratic formula. X is equal to negative b plus or minus the square root of the discriminant is underneath the radical sign over 2a. Okay, b squared minus 4ac is called the discriminant. What does that mean? It means that it discriminates between the following three cases. If b squared minus 4ac is some positive number greater than 0, then we have a situation with two roots. If we have b squared minus 4ac, when you get to this point in the quadratic formula and it's equal to 0, and you're taking the square root of 0 there, that means you're plus or minus 0. That means you're plus or minus nothing. That means you only have one root. There's only one solution to that quadratic situation. There's only one value of x that will work, and it's negative b over 2a. Graphically, it looks like this, where the only root is the vertex. Okay, that's this situation. Graphically, this one, of course, is when you have two roots. Boop, boop. Okay, and then the last situation that the discriminant discriminates about is when this is a negative number. Okay, if you've been asked to take the square root of a negative number in here, then that means that there are 0 real roots. There's no solution to that situation. So that would look like this graphically. It never touches the line y equals 0 or the x-axis. The quadratic just misses, okay? So one way that you can use this to your advantage is if you're instructed to say how many roots does each one of these systems have, you just need to use the discriminant to find it, okay? So let's go. 10a. All right, I'm not going to copy out the whole quadratic. I'm just going to say a is equal to 3, b is equal to 4, and c is equal to negative 5. Okay, this one's going to have two solutions. I'll show you why. We're just going to use b squared minus 4ac. Okay, and so b squared is 4 squared minus 4 times 3 times negative 5. Okay, so then that's equal to 16. Minus 4 times minus 5 is positive 20. 20 times 3 is 60, so 16 plus 60. This is equal to 76. 76 is bigger than 0. Therefore, 10a has two roots. We haven't been asked to find the roots. We just want to know how many there are. We know there's two, so let's keep going. All right, 10b. What's my a? My a is equal to negative 2. My b is equal to 5. And my c is equal to negative 1. Okay, so b squared minus 4ac is my discriminant. Let's sub in. 5 squared minus 4 times minus 2 times minus 1. Well, this one has 2 as well. Because here we go, 5 squared is equal to 25. Minus 4 times minus 2 times minus 1. There's 3 negative signs there, so we know that the answer will be negative. 4 times 2 is 8. 8 times 1 is 8, so it's 25 minus 8. Last time I checked, 17 is also greater than 0, so we have two roots. 10z. Okay. 9 is equal to a. Negative 12 is equal to b. And 4 is equal to c. Well, this one has 0 roots. And I'll show you why. Because are you impressed that I do that fast in my head? Nah, I just really know the number 144 inside and out. Hold on one moment. Okay, let's keep going. I just know the number 144 really well. Okay, b squared minus 4ac Notice I copy the formula out every time. How many of you do that? No, not many hands went up, eh? So maybe you want to think about that. You want to be a formula copier like me. Okay. Well, let's do this. 12 squared is 144. But I can make 144 another way. I can take minus 4, multiply it by 4. That gives me minus 16 times 9. Gee, I wonder what 16 times 9 is. Let's find out. 16 times 9 is equal to 144. Oh my goodness. 144 minus 144. What are the chances? This is equal to 0. Therefore, there is only one root. Okay, there was one more question in section 1.5. Let's take a look at it. It's in the it's all in the D2L here, right? So let's go here. We'll open this up, and then I'll zoom in. Zoom in. Why can't I zoom? I can't zoom, guys. Sorry. Here, watch me fumble with my technology here. Bam, bada, bang, 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 bang. This will give me a zoomable copy. Okay. Boop. All right, we make this big. All right, let's talk about Jessica. Jessica figures that since 2 times 2 equals 4 and 2 plus 2 equals 4, the root 2 plus root 2 must have the same value as the square root of 2 times the square root of 2. Is she correct? Well, what do you think, everyone? No, she's not correct. She's not correct because the square root of 2 is not 2. 2 has this special property. 2 2's is 4. 2 plus 2 is 4. Yeah, we've noticed that before. Probably you've noticed that 2 plus 2 is the same thing as 2 times 2. That's the special property of 2, and that's it. Okay, not the square root of 2. Square root of 2 works a little differently. Square root of 2 multiplied by the square root of 2 is 2. The square root of 2 is not 1. So we would have 1 plus 1 here if that were true, but it's not. The square root of 2 is not 1. So the square root of 2 is like 1.41 something, something, something. So we know that root 2 plus root 2 would be like 2.8. And that's not root 2 times root 2, which is 2. Okay, so that is section 1.5. Any questions, send me an email. Otherwise, thanks very much for showing up for your learning today.